Hello world. This video will be about basic computer architecture and how it relates to reverse engineering. This video is pretty important because you'll learn about registers and CPUs, different architectures, processes, and all that kind of stuff. The topics I'll be covering in today's video are a high-level view of computer architecture, what a motherboard is, what a CPU is, what caches and registers are, what random access memory is, what are hard drives, and why you should know all of this. This video will just be a light overview of everything. If you want to go more in depth, I can link some further things in the description. So let's jump right into it. As a high-level view of computer architecture, there are a couple things we have to know. There's the main part, which is the central processing unit, and within the central processing unit, there's the ALU, the registers, some caches near there. Then there's memory, which can be like RAM. Then there's inputs and outputs, basically just like instructions, what you tell the computer to do by clicking on the keyboard, by using applications, all that sort. But how does it all communicate? Well, that'll lead us into our next thing, which is the motherboard. So what is the motherboard? You can think of the motherboard as the backbone or the spine of the computer. It doesn't process any of the data itself, but it allows for all the connectors and connections to transmit data. It allows the CPU to talk to the RAM, the hard drive to talk to the CPU, all that kind of stuff. And from a computer building perspective, you put the graphics card on it, you put everything on it that you could possibly need. An important distinction are between the wires and the buses. The buses are like the built-in traces, the little pieces of copper. They're really, really fast. And then you have the wires, which are used for things like hard drives, like spinning hard drives. Then the buses, they communicate with the RAM, they communicate with the caches and registers and all that sorts of stuff. So just remember that the buses are built in and the wires are exterior. Now we can get into the CPU. CPU stands for Central Processing Unit. It's basically the brains of the entire computer. It does all of the actions that you see. The CPU contains the Arithmetic Logic Unit, also known as the ALU, which is the part of the CPU that does all of the math required for computation. The way that it processes all the data is through opcode, which is then turned into binary. Opcodes are like little shortcuts for how processors process data, and then binary is ones and zeros. It's the super raw form of data. It stores all of its instructions in little things called registers, which we'll get to soon. It also has caches nearby, which are the quickest form of memory, and so you'll usually see caches and registers mentioned together along with the CPU. Another important thing to know is what are threads and what are cores. Cores are basically like different parts of the CPU that can process data on their own, and threads is how many processes, how many data streams each one can process. So if you had a 4-core CPU and it had 12 threads, then 12 divided by 4 can easily tell you that there are 3 threads per core. Another important thing to know is x86 versus 64 versus ARM architecture. 86 is the old way of processing data. They typically used 32-bit integers. Nowadays we have 64-bit, and on smaller things like phones or Raspberry Pis, there are these things called ARM processors, which consume less power and are less powerful in the long run, but still, they're pretty powerful for their size. Now we can get into the fun stuff. What are caches and registers? You can think of cache as memory, and it has the quickest access time of any memory because it's literally right next to the CPU. It travels across a little bus and gets read almost instantly. It's temporary storage, so every single time the computer gets powered off, it gets wiped, but then it communicates with the RAM to get more memory just so that it can have a stockpile for what's coming next. Registers are built into the CPU. It's like a giant list of instructions that are in order for the CPU to complete. To learn about reverse engineering, you have to learn a lot about registers and the different types with the different architectures, like 64, ARM, all that kind of stuff that we covered previously. But yeah, you can just think of cache as quick memory and registers as the next set of instructions that's necessary for the CPU to complete. And when reverse engineering, you'll notice that many variables are stored in registers. And also another important thing, every single time a register is done with, it automatically increments to the next one, which is a pretty cool feature. So there are quite a few different registers, which I'll cover in a later video. The next subject we'll talk about is memory. In this specific instance, I'll be talking about random access memory, or RAM. Like cache memory, it is volatile, which means that whenever you turn off your computer, the memory gets wiped. It's a lot quicker than hard drives due to the access times and the frequency at which it transmits data. Since it uses buses and is a lot closer, it's a lot quicker. It's harder to do forensics on as well, because whenever a computer gets turned off, it gets wiped. So if a virus's last thing is to wipe or to turn off, then all the memory goes. In a future video, I'll go over forensics with RAM, how to capture it, how to manipulate it, what to do with all of that kind of stuff and whatnot. This leads into our next thing, hard drives. There are three main kinds of hard drives. They're the spinning disk ones, magnetic disk, if you want to be smart. Then there's the standard SATA SSDs, which have gotten really common in the past couple of years. And then starting to be even more powerful than all of those is the NVMe. The HDDs are by far the oldest hard drives. They're also the slowest ones. They're this giant chunk of metal that spins really quickly and it reads data off of it. Think like a CD or DVD. Then you have SSDs, which are like soldered on PCBs that are able to contain a ton of data. Then there's the NVMe, which is stuck directly onto the motherboard, which means that it's able to use the buses a lot easier, a lot quicker. The HDDs tend to be very vulnerable to magnets since it's a giant metal platter. If it raises a little bit, then it scratches and the disk becomes ruined. SSDs and NVMEs are more susceptible to electrical shocks, so that's why it's always important to ground yourself before you touch them, because you don't want static to wipe out all your fun files. So, circling all of this back to reverse engineering, why is it important to understand computer architecture? It's important to understand how data is stored and processed, how it's utilized, all that kind of stuff. And with that basic understanding, we can start imagining what we're doing by reverse engineering software, how we're cracking it and exploiting it and building it back better. It's also a good understanding of how to build a computer. You know what the necessary components are, what the basic ones are, and you can do so much more with that. And here's a small list of where to get more resources to learn about computer architecture and whatnot. There are quite a few more if you just look up on YouTube some playlists and tutorials. And so that's a wrap on today's video. In the next video, I'll be talking about binary and how data is represented in bits and hex and base 64 and all that kind of stuff. So, see you next time.